Yes, ma'am.
Okay, so I think we couldn't complete this chapter in the last class. The internet is very bad today. So just in case if my voice isn't audible to you or anything happens, please just inform me in between. Okay, so let me just quickly revise what we have already covered. This wasn't completed in the last class, and we started with a topic, elastic collision in 1D. All right. So what all things we have seen, let us just quickly revise. So basically there's an event that we have, which is known as elastic collision in 1D, and we've already talked about it in the previous class. So two major things are there that you have to focus on. Okay, so Nabia is also joined. All right. Nabia, you've already attended one class. This is the collision one. All right, the gravitation one was there in the other one. Yes, class. I was discussing that initially here the momentum remains conserved and the kinetic energy. Both of these things are conserved in the elastic collision in 1D. And there is no conservation of kinetic energy in your inelastic one, which we'll start in today's class. So initial momentum is equal to final momentum. This we have already discussed. And coefficient of restitution also we have discussed in the last class. Okay, we didn't practice any numericals. From here we have to. Sanidhi, is your exam over?
Yeah, ma'am.
How was it?
Ma'am, it was very hard, but then some of the questions we have done came. So I did those questions.
Okay. All right. So did you share the paper?
No, ma'am. I'll share it.
Share it. It will give me an idea so that we can have a discussion. So here two masses are present. 5 meter per second is the velocity of one, 4 kg is the mass, and 2 meter per second is the second. Now, the first body of 2 kg is moving with it with some velocity 5 meter per second towards the right side. Okay, and 4 kg is moving with 2 meter in the opposite side. We'll have to use the formula that we studied here. V1 is equal to U1 M1 minus M2 plus 2 M2 U2 by M1 plus M2. Okay, V1 is equal to U1 M1 minus M2 plus 2 M2 U2 by M1 plus M. So M1 is equal to 2 kg, M2 is equal to 4 kg. We'll choose up a sign convention class. Like if we are moving from the right to the left, that will be taken as positive, and if we go against it, that will be taken as negative. Okay. So in the question, it is already specified to take the direction from the left to the right as positive. So this will be positive, this will be negative, right? So we'll have to put in as it is. So U1 will be equal to 5 meter per second, U2 will be equal to minus 2 meter per second. Now see, let's put in the values. V1 will be equal to U1 is 5, 2 minus 4 plus, this is 2 into 4 into 4. Okay, if this is also 4, M2, and U2 is minus 2. And then the sum is 4 plus 2. So this is minus 2. That makes it minus 10. And this is already minus. So 4 and 4, 16 minus 16 by 6, which is minus 26 by 6. That is minus 13 by 3. Okay, this much meter per second. Now, minus sign represents clearly that the direction that we have chosen is in the opposite one. The direction of the final velocity is in the opposite direction. Because what was the negative? Right to positive, right? Similarly, if we talk about the second velocity, V2, this will be equal to U2 M2 minus M1 plus m1 u1 divided by m1 plus m2. So we'll have to put in the values here. U2 is -2. This is 4 minus 2 plus 2 into m1 is 2, u1 is 5, 4 plus 2. This is 2. 2 into 2, this is -4. This is 4. This is 20 plus 20 by 6. That is 16 by 6. That is 8 by 3 meter per second. Now this is coming positive. So what can we conclude? We can say V1 is the final velocity of 2 kg body, which is 13 by 3 meter towards the left. And V2 is the final velocity of the 4 kg body, which is 8 by 3 meter per second towards the right. Now, few special cases and here and there contexts are there. Let us just complete it. First, you copy down this question till the velocity part you have already written. And I'll start with rotational motion today itself. Okay, please write it. Okay, see, now let's talk about the special cases. Few special cases are there which you should remember as it is. If the masses are identical, okay, m1, m2, they all are equal to the main mass, that is m. So here m1 and m2 will be equal. So eventually the masses will be cancelled. So v1 will be equal to u1 from here directly, and v2 will be equal to u1 from here, because the 2 will also be cancelled. So actually what happens is the initial velocity gets exchanged with the final velocity. Second is if m2 is very much greater than m1. See, m1 minus m2 will almost be equal to m2, because see, m2 is very huge. So m1 colliding with m2 will not affect or impact m2 much. And similarly, m1 plus m2 also, when you will take, it will be m2. It's like if you have a number 10,000 and you have a number 10. So when you add 10,000 plus 10, you can round it off and write it almost equal to 10,000. So this is the case. Mass is very huge, and it's not just greater, it's very, very greater. So V1, when you put in the values, this is the final result which you will get. V1 is equal to U1, V2 is equal to U2. This you can check while writing also. Basically, no change. Means the final velocity will become the initial one. Means as it is, whatever were the initial velocities will remain the same. Similarly, just the opposite for m1 is greater than m2. Okay, these are three special cases. Then in lastly, let me discuss. Just write down these three special cases. Let's complete the chapter and start with rotation. Okay, let's talk about the inelastic collision in 1D. As I discussed with you, here the momentum remains conserved. So m1 into u1 is the initial momentum of the first body, m2 into u2 is the initial momentum of the second body. So m1 u1 plus m2 u2 is the total initial momentum. Then finally m1 v1 plus m2 v2, this is the total final momentum. But here, in case of kinetic energy, don't make any equations. That's invalid. Just use this equation. Kinetic energy will not help over here. Okay, because kinetic energy isn't conserved here. So directly using m1 u1 is equal to m2 u2 is equal to m1 u1 plus m2 u2 is equal to m1 u1 plus m2 v2 will be there. Now there's a case of perfectly inelastic collision. Perfectly inelastic collision means both the bodies are moving. They have their individual initial velocities. Okay, they are moving with different velocities. They collide and then they stick together. They do not separate. So whatever will be the velocity will be the same velocity of both of these. That is known as the common velocity. If I write the momentum conservation equation, m1 u1 plus m2 u2, this is equal to m1v plus m2v. So m1 u1 plus m2 u2 is equal to, let's take v common, that becomes m1 plus m2. Now if I bring this velocity in the denominator, means this m1 plus m2 in the denominator, I'll get m1 u1 plus m2 u2 divided by m1 plus m2. So that's known as the common velocity. This is known as the common final velocity. Okay, common final velocity. Like, look here, this doesn't say anything, this question, but this gives us a hint that they both have stick together. It means this is the case of a perfectly inelastic collision. Okay, so we will be m1 u1 plus m2 u2 divided by m1 plus m2. So v will be equal to m1 is 2 into 5 plus this is 3 into 2 divided by 5. No, 3 plus 2. This will be 3 plus 2. That is 10 plus 6 by 5, 16 by 5 meter per second. So this is what you need to remember. Let's then see the 2D one. 2D one is a shorter topic. Let's complete it. Okay. Is it clear to all till here? Elastic, inelastic, and all.
Yes.
Okay, write it. Okay, coming to the elastic collision in 2 dimensions. 2 dimensions, what happen when the bodies they collide with each other? When the bodies do not move in a straight line, that is what is meant by elastic collision. So the bodies get deviated in different directions with some angle with respect to the x-axis. So with the velocities that are present with respect to the x-axis, let's say some theta 1, theta 2 is made. Theta 1 and theta 2 can be equal also, they can be unequal. So what we do, the difference that arises is that we resolve the components. You get the x-axis component v1 cos theta and v1 sin theta. Here you get v2 cos theta and v2 sin theta. Now, when we talk about the conservation of momentum here along the x-axis, so initially it is m1 u1 plus m2 u2. Second one is m1 v1 cos theta. This is m2 v2 cos theta. Okay, along the y-axis there is no initial momentum, so that will be 0. But final is there, mv1 sin theta and mv2 sin theta. So we put them. Now see, these two velocities are in the opposite direction, one up, one down. So we take one as positive, other as negative. So this will be v1 sin theta minus v2 sin theta. So in fact, along the y-axis, you get the equation m2v2 sin theta 2 is equal to m1v1 sin theta 1. Okay, kinetic energy is conserved. So half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. This is the kinetic energy because you talk about the speed. In speed, you don't need to resolve it. Okay. This is write down this elastic collision in 2D. Done. Let's start with rotational motion. Yeah. See, the chapter is motion of system of particles and rotational motion. So understand what is the meaning of it, each one of you properly. Now this is a fresh chapter. A little link is there with the previous chapters definitely because it's a part of your mechanics. But since it's related to rotation, new concepts are there. Get them clarified. If there's still a doubt, please ask me in between and revise your work, energy and power. Okay, keep on revising it. That's a very easy small chapter. Now here this is motion of system of particles. See, when you have any object present, there are microparticles that are present here. Okay, all this is at the atomic level. Lots and lots and lots of particles are present. Okay, all of these will have the velocities. All right, so motion of system of particles and rotational motion. So what will be there? Every particle will have velocity. This will have its own velocity. This will have its own velocity. This will like this. All the particles will have velocity. So when we have all the particles combined motion, see, one particle is there, we call it as a particle. When many particles are there, we call it as a system of particles. Okay, system of particles. So there are various particles that are present. So every particle is moving in a different velocity, v1, v2, v3 and on. Okay, now when you talk about entire body's movement, you can't talk about the individual velocities of each and every particle present. So what we do, we take them, we talk about the total velocities that are there. So that velocity is actually the velocity of the center of mass that we'll study later. So this is what is meant by system of particles. Means the entire particles, they are moving, all the entire particles are moving. That is known as motion of system of particles. And then we begin their rotation. When they begin their rotation, that is termed as the rotational motion. So two parts are there in this chapter. Majority of it we have already done in the laws of motion, which will not be repeated. So please revise it from there. Now, what's a rigid body? Body having a definite shape and size, and during motion, the separation between the points do not change. This means that if we have, okay, and there is separation, let's say two particles are there. Now, if I zoom in, these two particles, let's say have this much gap in micrometers and all. Now, even when the body is moving with certain velocity, the gap between them, these two particles will remain the same. That's a rigid body. There is no change. Very greater external forces are required to change it. Means external forces can only change, internal forces do not affect. And when we talk about the system of particles, they can have different orientations. Like the particles can be discrete. Like all the particles, they can be present like this. Diffused, you can say diffused. Or they can be continuous, like they can be in an organized array. They can be present and very compact, which cannot be seen just like this. And when we talk about the motions of these rigid bodies, there's a translation motion. The rigid body will move forward and backward. Translation motion means the body moves forward and backward. Second is rotational motion, means the body will rotate. Okay, so forward, backward, rotational. And then when you combine these two, that is known as a rolling motion. Best example is tire, means this is rolling also and this is moving forward also. So from the translational part, we will be discussing the center of mass for the particles. Then we'll start with rotational. Okay, so is it clear till here to all?
Yes, ma'am. Ma'am, which topics should we revise from laws of motion?
For this chapter,
Yes, ma'am.
circular motion angular
Okay.
displacement, linear velocity. Before the dynamics of circular motions heading, that entire dynamics is just for laws of motion, but revise that because this is connected to it. In your exam, everything will come. We did there so that this chapter is easy for us. Okay.
Okay, ma'am.
Okay, see, let's start with the center of mass. See, what is center of mass? Like I was describing you that there are many particles that are present in a rigid body. Now, every particle will have its own position, will have its own velocity, will have its own acceleration. So you need a point that can represent all of these, right? Means there should be a point where you can replace the entire body, and that small point will represent the entire, as if the mass of the entire system was supposed to be concentrated at that point. So that point is known as the center of mass. It's valid in translational motion only. So as I discussed with you, I'll be just starting with the translation motion first. So let's read. This says that point at which the entire mass of the system is supposed to be concentrated. It can lie in outside the system and valid for translation motion. Like if I have an object is there. Now this object, let's say this is its center of mass. So what can I do? I can replace this with just the center of mass, and whatever will be the average functions of the rest of the particles will be done by this. Okay. So how do we write the formula? How do we derive it? M1 is the first particle, M2 second, M3 till mnth you have it. And R1, R2, R3, R4, they are the separation from the origin. The original formula of the center of mass is M1 R1 plus M2 R2 plus M3 R3 M4 R4 like this, divided by the total masses. Okay, M1 R1 plus M2 R2 plus M3 R3 M4 R4 like this, divided by the total masses M1 plus M2 plus M3 plus M4 and all. Okay, so when we talk about the center of mass of x-axis only, like this is the general formula, but only for x-axis, this is M1 x1 plus M2 x2 plus M3 x3 M4 x4 till M nth x nth. Divided by the total masses present. M1 plus M2 plus M3 up till M nth, like this. Then y-axis center of mass. M1 y1 plus M2 y2 plus M3 y3 like this. M nth by nth. So when you write the total sum, it will be M1 plus M2 plus M3 up till M nth. Okay. Then similarly, if you have z-axis, then you're going to put for z-axis M1 z1 plus M2 z2 plus M3 z3 plus till M nth z nth divided by the total center of mass. So M1 plus M2 plus M3 total mass will be divided. Like this, you will have all of it. This is for individual axis, but actually the general formula is this one. That is valid. Okay, RCM, this is what is the position of center of mass. This is known as the position of the center of mass. Okay. Is it clear? Center of mass to all?
Yeah, ma'am.
Write it down. Done class. Still writing or done? Yes, class, is it done or you people are still writing? Others, Mariam, Nabiha.
Yes, ma'am.
Okay. See, now we'll have to practice some numericals like this. Look here, different positions of the objects are given. You will be given different placements of different objects and you will have to find out their center of masses. So what we do in such kind of questions, like see, it's pretty clear what is M1, what is M2, what is M3. Okay, like this will be M1, 1 kg. This will be M2, that is 2 kg. And this will be M3, that is 3 kg. So M1, M2 and M3 are there. Now you have to find out their XY coordinates. The best method is you find out their coordinates. Okay. In the coordinate system, it's very easy to distinguish the X and Y parts. No? So what you do, like here, this, and this. Now you have to find the coordinates of each and every body from here. Okay, so I'll not continue further because this will require a little time and I think we are short of time right now. Tomorrow I'll complete this. And then I think center of mass probably will be over tomorrow. Let's try to complete the center of mass topic. Okay then, any queries, anything?
No, ma'am.
Okay, Mariam, you just stay. Others you can leave now. Okay, Mariam, you just stay.
Thank you, ma'am.
Yes, Mariam, I wanted to talk to you. What has happened to your score? I received your marks. They are very less. What's the problem you're facing?
So I don't know.
Are you able to understand? See, one thing that I told everybody that in between you were very irregular with the classes. I don't know what happened. I think your exams were there, you were sick or something, you were irregular with the classes. Initially, you were good, but in between, very few classes you could attend. So I think it may be one of the reasons. But like, is there any trouble you're facing with any problem in the class? Anything you're not able to understand? You want the practice to be done? What do you feel, Mariam? Just tell me.
Uh, the first two lessons were nice. After that, I lost interest. That's one reason I think.
Yeah, so that's the problem. No, you don't have any option of losing the interest or gaining the interest. You have to
Yeah.
develop your interest. And secondly, Mariam, during the first two chapters, you were regular also in the classes. Then you didn't
Yeah,
come.
because I liked it.
Hmm. Okay, but you have to practice Mariam properly. I think we see you are doing okay. It's not that you're doing very bad or something. I just felt that if there's a specific problem with physics, you can definitely discuss it with me. Are you practicing properly? Are you practicing ample amount of questions in the class?
Yeah, Miss, I think all five lessons together is hard. Like
Or
all
you
together.
want under five chapters in the exam to be done?
Yeah.
Okay. So, Mariam, practice more number of questions. No, because in the final exams, you'll not just have these five chapters. Book one plus book two will be there. It's not just about these
Yes,
five
Miss.
chapters. All the chapters will come, second book will come, questions will be merged from one chapter to another chapter like this. Questions and everything will be there. Okay, Mariam. So please practice. And if there's any doubt in the class, please get it clarified. Okay. And remember one thing, you can't lose or gain interest as per your wish in class 11. Problem is that whatever you have opted, now you have to abide by that. You have to get good scores in that. And physics becomes really hard if you don't practice much. So I'll suggest practice properly. Your assignments and all are good. You're regular with the assignments too. So you'll be able to do good. Just practice.